Smoke testing. Today I want to show you a bit what smoke testing is, how it works, what it's for, how it's done. But first, let me introduce myself shortly. I'm Sebastian. I have an own small company. It's called SmokeTests. And in the meanwhile, or in the meantime, I'm still working as the chapter lead for the Better Venture Groups. A short history on where everything starts and how we actually came up with smoke tests. So I go a bit back in total 8 years. 8 years ago, a company called Kartenmacherei was founded. They do pretty much invitation cards, personalized for any kind of emotional events. I joined this company in 2015. It's a family-owned company. It's completely without any external capital in there. Everything is family-driven. In the 8 years, this company grew to a total of 5 ventures, and therefore we decided last year to put a new holding on top of this to make everything a bit easier, clearer. We are today, the number at the top is wrong, I see. It's not 160, but we are 190 employees plus production centers. And a total out of this is about 25 tech people, so 16 backend PHP developers are working with me together in the team or across several teams. And that's enough for the history, that's enough for the company. Let's look into the agenda. I want to start with you first on getting all on the same level of about testing, of what means testing, where we had, what we should do. The second level is explaining what are smoke tests. The third is how they work. The fourth, I want to show you which kind of server setup you need in order to run smoke tests smoothly without affecting your live system or taking down your own server, your own website. And if someone is too lazy to code this yourself, there's software as a service available as well. I will show you shortly that at the end. But let's start with a couple of questions, and there I really need your help. And that's the first question is, who's familiar with software testing in any kind of way? Okay, I expected a few more hands. Okay, that's good to know. And who is familiar with PHP unit? Okay, that's pretty much the same amount. That's good to know. So PHP unit is the library which we use for smoke testing and for any kind of testing. At the Better Ventures group. And we decided in 2016 that we want to follow the testing pyramid. Who's familiar with the testing pyramid? Okay, then you can sleep for the next 30 seconds, okay? Good. The testing pyramid, our testing pyramid resides out of 4 layers. Usually it has 3. And it shows a few things if you look on these layers. You see the layers at the bottom are quite wide, the one at the top is quite small. So this is about the tests, this is about the amount of tests. So you have a lot of tests at the bottom, you have just a few tests at the top. And that's simply necessary because you want to, on the other side, you have the performance of the tests. The tests which lay on the bottom, they should be extremely fast, but the tests which are at the top, they are quite slow. So if you have a test at the bottom, which takes more than a couple of hundred milliseconds, it either is not belonging to the bottom, or it's just wrong. So, but let's go into more details what these layers are. And the first layer is the unit tests. And unit tests is not equals PHP unit. So unit test is a concept. It's not PHP unit or JUnit or any other library, testing library which has the word unit in the name. It's not equal. Unit testing is a concept. And I want to show you this on a pretty simple example. So you have 4 classes. And unit test simply says test a unit. So we want to test the unit of class 1. So you know it yourself, classes are quite depending on each other. If it's old code, it's usually not even following solid or has dependency injection. That's getting tricky to test with to build unit tests for this. But if you really follow the concept of unit testing, you're automatically writing better separated code, better domain-driven code, simply because you want to test this properly. And therefore, in a unit test, you have the benefit of saying, okay, everything which my class 1 depends on, I mock. So, and this is the direct dependencies, but the next one is the fourth class is automatically mocked with it. So a unit test should simply test just the behavior of one class, so of one unit itself. And everything else is mocked. And these tests are not there for testing internals, but it's there for testing just the behavior of the class. So if you want this class to output a string, test if the string is outputted correct. Don't test if internal in this class the right variables are set. That's not the matter of this test. Okay? But let me show there 2 more examples where unit test is not enough. And it's simply, that is the first example. Some of you might have seen this already. The unit itself, the toilet, is working. But is this working as an integration? Simply not. And there was a second case which actually happened to me. I went last year to the Philippines, and I saw this. There is this lock. This works perfectly as a unit, but the integration is simply stupid, not working. And that was not somewhere in the middle of nowhere. This was in the middle of Manila, in one of the areas where they don't have that much money, and that's first floor. So simply to crawl up and just slide the door, so don't leave your private stuff in there. So we need some more. We need some more tests. So unit test is not everything. So the next layer is coming up there is integration tests. And with the integration tests, we have the same example. This time we want to test exactly the integration between class 1 and 2. So don't forget these integration tests. These are necessary to make sure that if you change one unit, that the other unit can still work with this. So therefore, you mock just the class 3 and 4. We defined in our company that even for integration tests, like low-level dependencies, like hard drives, Redis, databases, all of this is still mocked on this level. So all of this is still mocked, so you really test just the integration between 2 units and test them, and everything above should be still mocked. So that leads to the point that you have now the integration between all classes done. So, and one good example for this is factory classes. Then you have a factory class, the only unit test you can do is you can check if you can instantiate the class. That's the only thing you can test on a factory. But the factory itself is, if you want to test that the methods are returning the right objects, then you can use integration tests, and it's automatically the concept of integration tests if you have all methods covered in there. And together, unit tests plus the factory tests in our company have to produce the 100% code coverage. So we have strict rules in our company that we have to have these 100% code coverage, otherwise a pull request is declined. That works quite well, and I have to say I never believed this before. I'm seeing this now since 2016 running every day. Since then, it feels like we have about 80% less bugs in the system, since we have these strict rules on how to define unit tests, how to define integration tests, and the code coverage. But as mentioned, some parts are still mocked, so we need something more, and that's the acceptance test. And the acceptance test, we define them, or a lot of people define them on a different way. An acceptance test you can simply do with Selenium and run your application and see it in a browser. That's one way. But if you have backend logic, if you have really like complex behaviors, like in our case, like producing print PDFs, then we use acceptance test as the layer and say, okay, here's nothing mocked. Here's just different kind of database connection that it's not against the live environment. and have everything there, so nothing is mocked. And it's a real end-to-end test. So you really instantiate the factory, you really instantiate the application, and then run the whole application for this. That was where we came from. So in 2015, I have to get a bit around there. In 2015, 2016, we had decided, okay, we have our old monolith Magento, and we want to, and no one from the front-end department wanted to touch the front-end anymore. That was like too many people, too many cooks. So we said, okay, we need a new front-end. And we built a new front-end with a whole new architecture below, that the front-end is generated once an hour from the database, like generated markup, put into a storage, and shipped to the customers. So, but then we realized, okay, these 3 layers of tests, they only run in your development or in your test environment. But who's making sure that when we deploy every hour, that all the 20,000 pages we have are still available? So we needed something more. So, and then that was the 4th layer of our pyramid. And we needed something more, and we decided, okay, when we have this shop frontend, we want to deploy this hourly, we have to set up something. So then we came up with smoke tests. We heard about this concept, and smoke tests is my first question. Who is already familiar with smoke testing? More than expected. Thank you. For the ones which are not familiar with smoke testing, that's what smoke testing is. That's where it comes from. So it comes mainly, I learned it the first time in the US, and it's there to check if sewage canals, drainages, everything still is working, or if they look for a hole in there, then they just put a smoker on top of one of the entrances, close every other entrance or where it could disappear, and just wait. And wait and see where the smoke is coming up. That's where the non-IT version comes from. And we looked at this and said, okay, why not doing something similar with our websites? So we said, okay, we have a fixed set of URLs, we know. That's the URLs we start with. And why not running tests against them? So why not testing these URLs at least with a minimum required test that they have in common? So what we expect, for example, that it's available and it's not like 404 page not found. And so that's the idea of smoke testing in software. So what to test there actually? As mentioned before, we all did all of this in regards to we needed a solution. So we needed at this time a solution. We had no time because usual deadlines, get this shit live, make sure that every page is still there and not some requests go to the old system. So we came up with this solution. If you have additional ideas, better ideas of what is coming now, please approach me because we still learn. We still want to learn on how to improve all of this. But we came up first with a set of tests, like what should a smoke test do? And we came up with something like, okay, it should be simple. It should be fast. We should have optional parameters as well. So if your website acts different depending on the parameters at the end of your URL, just add them. And as well, what was for us quite a discussion point was the last one. It's the manual list. Never generate the list of smoke tests out of the available URLs you have. Because if out of your 20,000 URLs you have, 10,000 are not in that list anymore, not deployed, the 10,000 are missing for the smoke tests. So you would get green smoke tests, but it's not working. So we really defined that it should be a manual list. And what there is even more important is that you train the non-tech people. Because the couple of days after we launched, they said, yeah, the smoke tests are red. Why are they red all the time? Like, yeah, this URL is just gone. Where is it? Where it disappeared? So we were debugging for 3 days in order to find out that simply one non-tech said, okay, this URL has a small spelling mistake. So I changed this and forgot to redirect. So it's not just supporting SmokeTests are not just making sure that your pages are there, but it supports even that you don't forget the redirects, because if the redirect is missing to the correct URL, it's broken. So what should the smoke test now validate? We decided for these 4 points. First, the status code. Second, that the speed is correct, because when we started this whole project of the new front-end, we got only one real strict rule from our bosses, and that was 200 milliseconds. Deliver the page done to the customer, like have a time to first byte below 200 milliseconds. And we took it with Star Trek. We said, yes, we make it in 100. And that was our rule, so we said, okay, we check the time to first byte. We said, okay, we will go a bit further. We say, okay, we want to check that the body is provided. And because of our architecture, in our architecture setup, we said, okay, we take the correct server as well. Because if our new application is not responding, it's possible to respond correctly to the URL requested, we would just simply forward the request to the old system. So we had to make sure that the right system is responding. What we defined that what is not a smoke test is this one. Because while we were implementing, there were like product managers coming around the corner and saying, yeah, can I check that this div is there? And can we not check if this banner is available and this banner? I said, no. It's a smoke test, not an acceptance test, which you can simply do with Selenium. And you can simply run it with Selenium in the cloud, in all kinds of browsers, and you have all these checks. This is nothing we should do. But now how it works. And then for how it works, I have one more question. Who's actually already running smoke tests against their websites? That's more than expected. Thank you. Good. So let's start with an empty page. Let's talk about how this should look like in the end. And we would start with your application server. So that's your production system. This is something which is supposed to be live or soon live. I will go into details more on that one. On the other side, we have a CI server. For us, it's a Bitbucket pipeline / a Jenkins job, depending on new or old projects. And these ones are simply just sending a request to the live application. And we get a response back. And the response is 265 milliseconds, and there's a body. So that's green. In a case I try this URL, I get a 4 page not found. That's red. So in the case one single URL is already not working, the smoke test should fail. We had 2 ways at the beginning. We defined first that we said, okay, as soon as one test is failing, the whole execution stops, not to avoid, to save some time to get earlier feedback. Turned out not to be good if you fix one URL and you have 5,000 broken, because that takes ages before you get through all 5,000. Now we'll show you shortly something that's the code which we started with. So we simply used PHP unit for this. And then I have another question. Who's familiar with data providers and how they work? Good, that's quite a lot. That's good. And with this data providers, we said, okay, we will start at the bottom, create a list of URLs, put it in a data provider, and then run in this line there with the logic, like, okay, put a curl call somewhere, running it, getting response, tracking the response. That's a bit slow over time. If you have 20,000 URLs, and even with a fast website, even with 65 to 100 and a bit milliseconds, if there is an issue, we talk about 45 to 50 minutes. And if you have a larger website, and it grows over time, then you have more and more of these issues. So we said, okay, we need something how we can fix this, how we can solve this. And we said, okay, come on, let's try concurrency. Why not using concurrency? We looked into libraries. Curl is happily handling the concurrencies, is happily handling that all these callbacks you can simply, easily set up. And we said, okay, let's try this. So, and here it's just 3. We started with 20, and we went against one server, and we had the concurrency of 20. So if the first request might not be the first one you actually set up, but one request is coming back, the next one gets scheduled, the next request is coming back. Immediately, the next URL gets scheduled on that pipeline, and the third one, oh, there was something wrong, and still a new one gets scheduled. But as mentioned, we tried this with 20 requests, or 20 with a concurrency of 20. And we tried this against it was not live yet, this server, that was the good part, but it was still a server which was already set up to be live. And we got immediately a call from our hoster, that's not us, but we got immediately a call from our hoster. It's like, guys, you know that you DDoS yourself? So you know that you take down the hardware? So our hoster like, okay, what shall we do? Okay. Then we learned it's a simple curve. What for us went absolutely well is you can either solve this by putting a varnish in front of this, but we were not fond of varnish because like we built just a kind of a caching layer in front of like for our whole front end. So why should we put another varnish in front of this just to solve this problem? So we said, okay, like let's look into what's the problem here, because everything got queued up and it was still kind of slow. We looked into it and we realized, okay, we should take it a bit down, but not too much, because otherwise it gets slow again. So we ended up with a simple rule of thumb how to configure the concurrency for smoke tests. The concurrency for smoke tests is simply the amount of cores your hardware has minus 1. So just let's give one core to the server and take all the others for the requests. And then you have a nice setup which in the end looks like this, if you run this hourly. And I took this as an example because we have here some issues in there. So you see that we get here, this is the throughput, how many requests. So you see that we get here quite some high, and it goes down here. And at some stage here, the deployment failed. Simply because, like you can easily see here that the response time got so slow that the amount of requests you can fit in per minute goes low. So that deployment failed, and someone had to check what was the problem, had to solve this problem. And as you can see, there are these smaller peaks in between. These are like tries of smoke tests. So when someone tried, okay, it's failing, stop it. And at the end, everything works again. But now let's finally get a bit more into code. And you don't have to write this yourself. So we were putting our heads around how we can solve this, how we can spread this. And we said, okay, we do even talks about smoke testing. So why not creating a library out of this? So and that's the chance. We have created a library, a public available library, which is open source, which is MIT. You can use this, you can change it, you can contribute. Have fun with this. But let's go a bit more into detail what this library can do. And I mentioned PHP unit before. It's based on PHP unit as well. It's actually written in a way that it's still validly working on PHP 5.6. I know it's dead, but there are still a lot of companies out there which want to run this whole smoke testing on an old server in order to replace that old server with something new. So therefore, we agreed that this code is working on PHP 5.6 until PHP 7.3. The PHP unit call is simply starting the application, and there is the data provider and a single test in between. So we turned the behavior a bit around to have the opportunity to simply have better outputs, have better opportunities, have the concurrency set up properly. So we say, okay, the PHP unit will call the data provider first. And the data provider itself takes, with including the concurrency, care of testing your application, creating the list of results. So you get the HTTP responses back to the data provider generates the results, and then just the results are getting run in the single tests. And how does this look like? How can I use this now? And that's pretty much the main structure you have for for smoke tests. So this is the same structure if you run one smoke test or if you run 20,000. The structure is the same. But let's start with the data provider. The data provider looks a bit confused, but we will go through all of this line by line. And we start with the URLs. You have three options of getting URLs in the list. So you have either, you can have a simple array, or you can simply run it from a file. So if you have a CSV file with all the URLs in there, you can simply load it from file. Or if the URLs come from somewhere else, there is already an opportunity in there prepared that you can generate this list from URL objects. What you then define is the smoke testing options class, and in there you have the request timeout, the follow redirects, the concurrency, and the body length. What's body length coming up here? So body length here means that we have defined, okay, you can, for checking if the body is available, you don't need the full body. So you don't need the full body, so you can define in here what's the maximum of characters you want to have in your as value in this list. Because if you have URLs which have a response of 1 or 2 megabytes, and you call 20,000 of them, it's quite memory using, so therefore we gave the opportunity to lower this limit. And then in the end, we provide via the smoke test trait, which you can simply add, just a run smoke tests method. And that's pretty much already it. So this is like most of the configuration you have to do. So when the smoke test, when the test itself later is starting, then we have the opportunity in the test to really use this. So, and the data provider already did everything. So the requests are done, all of this. So when the data provider is done, the test example here starts. And there we have again the trait, smoke testing trait. And this provides a lot of additional functions. So we have additional assertions, like if it's a success result, if the time to first byte is met, or even if you want to check if in the header of your request, of the response is actually something you expect there. For us, we used the application server. We put an additional field in the header of our new front end to make sure that the request is not ending up at the old front end. So, because the old URL still exists, so we did this as well. And then we have here the result, so you can see that the result is either success or error result, and then you can use this across these methods. It's pretty similar as PHP unit, and it's easily extendable. So we have there, in the result object, we have there additional information, like which kind of URL was called, time to first byte, headers, body, status code, and you can even output the result as string, which gives you a nice way of, okay, this is either, it's simple for an echo. If you want to echo what kind of result object you have, you can use this. The trait itself, the smoke testing trait, has 2 additional methods you can actually override. This is the error and the success method. Error output and success output. These are used when you want, during the data provider run, they are getting called on each result. So you want to have a progress, bar during the execution of the tests. You can get this sorted. If you want to have already outputted broken URLs, then you can use these two methods. That's all of this together again, a bit small now, but that's the whole code, how you run smoke tests. That's everything you need with this library. The only thing you need as a base layer is you need a PHP, at least version 5.6. You need a composer, and it will call automatically PHP unit into the system, and you would need a curl extension. That's all what it needs to get the system running. And the output in the end looks like this. So the output looks like this. You have like 222 URLs were fine, one was breaking, and one was breaking for 404. And so was breaking for 404, and it gives you at the end of the string already the URL which was broken. So much for the code. So, but imagine you can imagine you should not and don't want to run this against a live environment. So how to set up your environment that you can actually run smoke tests without affecting your customers. There's this, it's so-called AB or green-blue deployment. So it's pretty simple. You have a web server at the front which is doing the routing, which is taking care of all incoming requests. And this web server knows exactly if the box A is active, and every traffic, all traffic, 100% of the traffic goes there, or your server B is active, and everything goes there. So let's assume box B is active, so we can actually deploy on box A. So box A is either, we usually take a complete new box, so you can simply, or we handle the box as if it would be new, so if there would be nothing predefined, pre-configured. So we have our deployment server which deploys our code. Then we do some configurations, so setting up, running some scripts, filling up some databases, key value stores, all of this. And then we run the smoke tests. And everything was fine. And then we were running smoke tests like this. And then we realized after a while, okay, there's something broken. Why is our, like every second deployment failed? Or not, it didn't fail actually, but something was broken. So we learned, never trust the direct access to this box, but all the time go via the web server. So we simply set up a second set of URLs on the head web server, and on there you have the opportunity to, with a second URL, go directly through the web server with your traffic to a dedicated box. So all of the smoke tests are working, all of the tests are fine, everything is green, so then now you can switch, and then you can simply deactivate from B to A at the top in the active box, and that happens seamlessly because you can simply change the configuration of, in our case, of an Nginx. And then when you reload, like the Nginx in front, all the requests which are already there go to the old system. All the requests which are new getting queued for the new system. And then it's got properly configured. But what happens now? The smoke testing failed because in the key value store something was cheesy. So any ideas what happens after this step? That's exact, nothing. That's the point. So that's the point, it really happens nothing, like in the sense of the server is not getting activated, the deployment is marked as failed, and the only thing which really happens is the developers get an email that something is cheesy here, that someone really needs to look into this. And in the next hour, this whole system automatically tries again if someone fixed it in the meanwhile. So that's, for us, the rolling deployment, and that's what helps us in order to get the whole system running. So much about smoke testing. And I promise you, if you're far too lazy to write even smoke testing yourself, there's something new, and that's smoke testing as a service. that is exactly, most of the features I showed you are available in there already, more to come. And that's how it looks like. Oh wait, sorry for the advertisement. The smoke testing is, you can easily set it up without even changing your application. We don't have the opportunity in there with blue-green deployments. This is something you need to set up. There is nothing you need to install on your system. You simply go on the website, put in your domain, everything happens. Everything is done automatically. Concurrency is by default at 1, so don't worry, we won't DDoS your application. If you want to increase the concurrency, simply you have to approve that it's your server. So then you have to do something, you have to prove that it's your machine, that it's not like used for DDoSing. That's how it looks. That's how a result looks like. This is the first result you get when you enter your domain on the homepage. You get, in this case, you see it's 25 URLs. Everything is there. At the bottom, you have the registration form. Just register. And in the meanwhile, you can find the email, the approval email in your mail account. We set up everything for you. So afterwards, you can simply have your settings already. These are the default settings. And even the last one, the automation, you can say, okay, it's automated. It's done every day, every week, every month. The smoke testing. This is something you decide on your own. The rest is already pre-configured. That's how it looks. So this is the result page of an application, of a website, or in this case of my website. And you see on the right-hand side how many results. You see an average time to first byte. So we test everything for you, and we let you know if something is broken. If you go into more details of a dedicated smoke test, then it looks pretty similar, but then you have the details on each URL, so if you need something more, you can check there. On a single URL, you can see history, so you see, okay, on this day, this website was a 404, or maybe even 502 if something is broken, and that's it. So you have everything as software as a service. I'm a bit ahead of time, but I hope you have a lot of questions. So I want to thank you already. And one more thing, the stickers are down here. So if someone wants stickers, just help yourself.
Okay, thank you very much for the smoke testing Anlage. We have questions for you, and there's a lot of them. So, fire at will.
Thank you very much.
Okay.
Have you considered using Postman for smoke tests? Yes, we actually have considered Postman. We tried it at the time, and it was kind of a problem with Postman because you have to run it on your local machine. So you can either run it on a local machine, or you set up really a system which has which can run via a proper CLI. And we said, okay, we are so familiar with PHP unit, for us it's not a problem to write it in there, and all developers have the knowledge of PHP unit in our team, so we simply said, okay, we take PHP unit, that's the easy part. What exactly is the additional value of smoke tests, given that you apply all other tests on your code base and the production stage setup is in the same? Okay, that's a good question. The smoke test, as I mentioned, is not run in a stage or test environment. The smoke test is all the time running as the last step of your deployment, as I showed, as the last step of your deployment inside or against the live environment. So this is your last validation step before you take this box active. Okay? Ooh, really good question. Who writes these tests? And is that QA or development? The test architecture and the base features, like setting up smoke testing, is in our case done by developers, simply because at this time we didn't have QA which had really deep tech background. Today, maintaining and adding new URLs, making sure that they are working, looking into this, if it's like as a first level support, is QA actually. Next one, what do we have here? Have you tried smoke testing software as a service applications that requires authentication to bypass 143? Yeah. This is done, yes. This is done in, I didn't mention it here, but indifferent if you have the library or you take the smoke testing software as a service way, everything is in there. So if you have basic out, if you need basic out and access levels, you can actually configure this. This is all just optional parameters. I left them out here. Yeah, same question, which requires the login. What it's not for, and that's a good question with the login. What it's not for, it's not currently not there yet in order to really log into applications, like if you have an internal application where you have an internal forum or something, that's not going to work with smoke testing at the moment, simply because you have to understand then the logic of the website. There are better options for this with Selenium, where you can really click you through and fill in fields. Or you can, I saw others already, they gave some extra basic out credentials. I don't like that way to the smoke testing, so the smoke testing app could go around the login, but that's a security breach, so don't do this, please. Let's say you have a large app with 10K classes, number of users, and no tests. Where would you start? Ooh, that's a good one. Where would I start? Simply at the place where I would change. So if I really have to touch one class, then I would start writing tests for this simple class to make this class testable, to make this class covered with tests, and then I go to the others. And there's a nice anecdote from Martin Fowler. I met him a couple of months ago in Hamburg, and he simply explained of how you should work. And if you're in front of your computer and you see something which is not nice and needs to be improved, and applications with your tests are usual having some issues, you should imagine you can only wear one hat, and your hat is either I develop a new feature or I refactor an application. And refactoring means not that you should replace the whole application, but refactor on just that small feature. So there is something in your way to get your feature running. Okay, put your feature aside, stash it, take off your development hat, take the other hat as a refactoring guy, sit at your computer, refactor the code to your needs, get a pull request sorted, come back to the system, everything is fine, okay, now I can work, put the hat away, get the developer hat again, and then unstash your changes and keep working. It's a really good example on how it should work and how it could look like, and I really can recommend anyone to do this. Okay, what else do we have? Yes, it is possible to run smoke tests against non-production servers. Sure, you can run smoke tests against any server. That's not a problem. But keep in mind, if you run it again against a non-production server, most likely something is different. A lot of people say, no, the hardware is the same, but usually, at least in the database, something is different. So in the data set you have in the background. So if you have, like for our case, we have in the live environment, we have 20,000 items. But if we would duplicate all of these items into our stage environment, we would duplicate in the background something like 35 terabytes of data into our stage environment. That's nothing our boss wants to pay for. So we have a stripped set, so we can't run simply the same list of URLs against the stage environment. Okay. Monitoring. Have you tried popular monitoring products like Zabbix web scenario tests? No, I haven't tried them yet. I'm aware of them, but that's more in QA topic. That's more out of my main focus. We came up with this idea. We used this until today. If you have more knowledge about Zabbix and have there some cool ideas for me, just please, I'm around the rest of the day. Approach me, let's talk about, because I'm willing to learn on that one. How should we test production from CI server? Changes are not deployed in that moment. We test productions here. Okay, I don't fully get that, because on the CI, the smoke test application for us runs on the CI server. So the CI server is the testing unit, is the testing server in the end. But we do the smoke test as part of the CI of the deployment. So we deploy the code, as mentioned, we change the configuration, and then we run the smoke test against the system. And only if this system everything is green, then we take this box active. Okay? Test, is it the same there? Yeah, that's a really good point. That's something I really forgot to mention. Don't underestimate delays, like network traffic. Like, don't have your website hosted in AWS region Dublin and run it from AWS region Frankfurt, the smoke tests. Get the smoke tests as close as possible to your application. Because if it's further away, these are, in the case of us, we have 20,000 requests. We had at the beginning, when they were separated in separated data centers, we had a lot of network issues. A lot of times the smoke test actually, like 3 cases a week, we still had that one smoke test failed simply because the network was not available. So get them close together, get them maybe even on the, if possible, depends on your setup, on the same hardware, or at least in the same data center, so you have the same information or the shortest possible communication time, because that will give you the best value. You can much stricter define the values of time to first byte. Because if you don't have network traffic, because it's not going via a lot of network cables, then you can identify the time to first byte much better. Okay. Last one, if you test your whole application already, isn't it enough to basically just test, for example, 5 important URLs? No. No, it depends on your, not even then. There is all the time something in your database, like if we stay with e-commerce, your e-commerce platform is like you have for each product information, you have meta information, you have additional details. And if you run your smoke tests just against the last, or just against 5 of your products, these 5 products might work, but there might be one single product you haven't thought about for the last 15 years, which might break your code. And that's what you want to test with smoke tests. You want to see that the full list of URLs is available, because you want to give to your customers the full list of products. And if you have a product, for example, an old DVD you never thought about anymore, and that's breaking the website, that's even hard to debug. And that's not, and you would have to go proactively looking after this product when it fails. So okay, there's an exception that pops up 15 times a year maybe, but it's not worth enough to look into this. With this, you see them immediately. So, and you have a strict rule that's working or that's not working. Okay, one more. If you test your whole application already, on what server do you test? Yeah, that's it. All questions are asked and answered. If you have more, I'm around the rest of the day. Just let me know. So, and again, stickers.
Vielen Dank, Herr Thoss. And now for the Mittagessen, actually lunch. So I'll see you back here at 2 o'clock sharp. Enjoy your lunch. Thank you.